But then also encourage people to just raise their I'll look for random.
So we will just say
we're going to start by having people. What's your Oh yeah.
no way. No, not
I think that's okay. So actually, I didn't do it with Christians of life. It's kind of weird.
Okay. So now that everybody's in, we're going to start the panel. So before we start the panel, there are two things I want to point your attention to on the board. So on the right, you can add your own questions if you don't want to pose them by raising your hand, or the ones online, you can add your question to the Slido. You can see the number of the Slido. So you can go to www.sli.do. Number is 6035824. So we were going to monitor them as well.
But you can also
raise your hand, yes. Although you will only get called once. So think about which question you want to ask. Then on the left side, we had a little bit of an experiment called Resurrected Scientists. We didn't really fine tune anything. We just had a student, Sam Shapiro, he from UIUC, he just prompted, I think, ChatGPT to answer the questions that we're going to ask the panelists, in particular to philosophers like Kant, Hume, Schopenhauer, Feynman, etc. So if you're curious what their answers are, one-line answers, you can look at this Google Doc. You can also find it, the URL over there. Anything else? So before we start the panel, we'll have all of you introduce yourself. Maybe, yeah, say where you're from, what you do, but maybe also what's your favorite tech that you're currently using that maybe not everybody is already using.
We're going to try to rotate around who starts, but since I'm right here, let's start with Konrad.
Oh, well, wonderful. That was a nice trick. Konrad Kording, I'm at UPenn. I'm broadly into neuroscience, collaborating with lots of experimentalists on the logic of what they're doing. I'm in a couple of departments. I otherwise am the co-director of CFA LMB.
And what's your favorite technology?
My favorite technology is anything that gives me causal inference.
Okay.
I'm Josh Batson. I'm at Anthropic working on interpretability, though I did a bunch of random stuff before that. And I think I'm sort of obligated to say my current favorite technology is Claude 3.5 Sonnet, which I'm very grateful to, because it means that like in my 1 hour between meetings, I can actually like run some code and experiments. And that used to take 2 hours, which I didn't have. And so it just got me under the wire.
I'm Florent Krzakala. I'm French, and I'm currently in Switzerland. I'm a physicist by training, broadly interested in math. And my favorite technology, what could it be? Okay, there is something that I love and hate at the same time, which are all these software that generate music, like Suno and everything. I love them because I'm amazingly impressed. And I kind of hate them viscerally because it feels like they are stealing something from musicians. And but they are really doing amazing stuff, and it's really an amazing achievement of generating AI.
I am Shirley Ho. I gave a talk earlier, but in case you missed it, I'm at Simons Foundation, which is related to this place, I guess, but it's in New York. And I'm also director of Polymathic AI, which builds generalist AI model for science. Favorite technology, I'm very seriously debating. So I use Copilot a lot because same reason that Josh was saying. The other thing I really like is called Undermined. I'm not taking money from any of this company, but it's like a way to really learn new things very quickly. So when I try to learn like a new domain science, I'm getting into like genomics, it like teaches me a bunch of things. I can go into the papers I can reference to. So I find it very useful. I'm sure they are, API call of some of these models you guys build.
Do I use this? Or
Oh, you have your microphone.
Hi, I'm Adam Klivans. I'm a professor of computer science at UT Austin. I'm the director of IFML, which is the NSF AI Institute for Foundations of Machine Learning. And I'm also the director of our online master's in AI program, which is, I think, the only AI online program, master's program at scale. We have 700 or 800 students who just started in the fall. And my favorite technology, I was going to talk about the AI for protein engineering that we're doing, and I was going to talk about AlphaFold, but my favorite technology is my Eleiko Swedish steel barbell. It's a piece of technology, right? It's just a steel rod.
Russell, you want to?
I'm Russell Impagliazzo. I'm from UCSD. I'm a CS theorist who doesn't really have a favorite technology. I really hate it all.
Okay, maybe I add my favorite technology, which is also close to Adam's. So I'm Fanny Yang from ETH Zurich. Also work on theory, also a little bit dabbling with medical things, causal inference. And my favorite technology is actually the pedal to turn the pages using this iPad when you play music. So that's really convenient when you play chamber music, or you can play with the orchestra score. You can just tap the pedal to turn the pages. Very simple one, no ML needed. Okay, so should we start with this? First question we thought about was in the wake of LLMs, etc. What skills do you think will remain important for human researchers in your field in the world of AI assistance? And how should we teach these skills? So we start maybe this way around this time.
Sure.
So everyone will say, you can say whatever you think, and then we will have a more interactive discussion and maybe also add audience questions too. So maybe Adam, you want to start?
This is a serious question. What is? Can you reread it?
Okay. What skills do you think will remain important for human researchers in your field in the world of AI assistance? If any, like this, what Misha we wanted to add.
Thinking.
To you.
Basic human reasoning will remain important. Can you be more specific about the question? Or I mean, when you say skills, you mean like mathematical skills, or
whatever skills you need to do research in your area, in your specific area.
And what will they remain to be important?
Yes.
Oh, yeah.
Or the last ones to be replaced if they will. Yeah, if there's any.
Oh, yeah. Yeah. Then I stand by just basic human reasoning.
What is specific about human reasoning? Maybe that, yeah. Okay. I mean, you can add more.
This is a very hard question. So let me play devil's advocate. I was recently at a book talk that Eric Schmidt has talked about his new book called Genesis. And he says, imagine a future where everyone has a polymath in your pocket. It's not related to polymathic, just he called it polymath, where it knows everything. And you can ask it anything. So at that point, what are we gonna do, right? If we start with that, and it's true for all research, like scientific discipline at least, I don't know about humanities. I think humanities is a little bit different, but science research where you can use data to learn a lot of the actual knowledge might be very tricky. So I think human reasoning, I feel like there might not be that many tasks left in the traditional curriculum that we should teach.
And for research, I mean, it's just for doing research to advance your research field.
I think reasoning is definitely one of them, or logical reasoning in general, being critical thinking, but do we teach them right now, actually?
That's a good question.
Like critical thinking is not really that prevalent already in the current curriculum. So I'm not sure. I'm being very devil's advocate here. So I'll pass the next one.
So there is this quote by a French philosopher, Claude Lévi-Strauss, who said, good scientist is not the one who gives the answer, is the one who asks the question. Mm-hmm. Even if you have a polymath in your pocket, you need to think, what are you going to ask? It's not even, and then there is, of course, a prompt engineering side of it, how you ask, but what are you asking, right? And so, even if we if we have something that can solve all problems, we still have to ask the question. And so the ability to ask the right question is a tricky one. And that's usually what I do, and I wait for my student to answer. So I already have polymath in my pocket.
Yeah, I mean, I guess we all have colleagues already, which are like people who know things that you work with, and that has not obviated the need to like think about things yourself. I think so. I mean, it's easy to try to jump very far in the future and like paint yourself like a sort of particular fantasy of like the end times of like whatever some convergence of like great intelligence would be. My experience, I mean, when I joined Anthropic like a year and a half ago, it didn't have a product yet. And ChatGPT had come out like 3 or 4 months beforehand. And it has been like pretty surprising to me in that time, like which things the models have gotten quite good at and which things they're still quite bad at. I expect we may, I mean, possibly even some of the like interpretability work, but other things could teach us about like limitations of this paradigm when you push it far enough. But I think it's not obvious right now, like which of these things are going to be correctable or not. And so I think maybe I would just advocate for a much more like adaptive strategy of like, you know, as long as you are curious and you have questions that you would like to know the answer to, you should like you'll use the tools available to you to try to answer them. I will say that like spending time with these models is valuable because they can do a lot more than you get by just like blurting out your question. Like some curiosity about capabilities is like quite useful, but even if you're very lazy, like your curious colleagues with that will like figure it out. And at some point you'll be like, you know, so I've got a friend who's, this is a very long answer. I've got a friend who's at LBL who doesn't use these models at all, but his like postdoc does all of the time. And they were doing quantum field theory question. And so what are you going to do? You're going to expand it out. You're going to do the path integrals and like, here's a Feynman expansion. And like, you know, the model like didn't do the whole thing, but it definitely did like the first 6 steps of it. And like, was a pretty reasonable starting place. And then you sort of pick it up from there. If the day comes where you never have to do, you know, Feynman expansions again, like physics won't be over, but like that part of it will be done for you. And I think that, rather than thinking like what will happen if models could do every part that like people can, it's just like, oh, they do some and then like we'll move over a little bit. And by the time, you know, it's actually a real problem, the world will be very different anyway, and we can deal with it then.
Wonderful. I use LLMs a couple dozen times a day, so I feel I'm getting really an idea on how to use them effectively. There is one key skill that is coming in right now, which is epistemic humility. That is like the ultimate skill, which is if you understand properly which things you don't understand, that is the superpower with LLMs. Not like they say things and then they're right or they're wrong, and kind of like, and it ties in with the critical thinking that you mentioned before. So epistemic humility is going to be the big thing, and we're not nearly enough training our students to have those skills. And we're not training ourselves enough to have that skill. Not like it's nice to publish papers, but like we're often not like as careful about what the papers actually show. That might change over time, where like LLMs can like over time get capabilities that are closer to epistemic humility. But there's one piece where they can never be useful for us, which is only us can know what makes a world good from our perspective. They don't have agency at all. What they do is they like imitate the agency of humans. Like they like kind of in a way average across lots of people what people stand for. But in reality, what's a good world, what's a better world, what's a worse world is something that fundamentally systems without agency cannot decide for us. No amount of intelligence gives you the ability to distinguish a good world from a bad world, because that is outside of the world. It's one of the big things that scientists get wrong, that they believe because of all their training, they kind of are more, they're better at saying what's a good world versus what's a bad world. But like this, what is it that we're trying to go for is something that can only come from us humans.
Thank you. So the follow-up question is, and let's like move the time threshold a lot closer to the present. What kind of skills used to be really important in doing your research and now are kind of obsolete, and we shouldn't bother training students in these? And I'll start in the middle, and then you can pass it either way.
You know what? LaTeX skills. Man, I remember these days when there was that guy, you know, like, and he knew where, you know, what to do so that the figure would be here, and you know, like, and these days I'm just asking ChatGPT, you know, like, oh well, you know, what should I do? Well, like, oh, this thing do not compile, and he just gave me this really enigmatic error, and man, that is unbelievable. But you know, we kind of solved LaTeX. And you know, that's impressive. Though I heard that Overleaf was done you know, it might not have been a big thing in US, but during all night it was down. And I can tell you in Europe, it was a big event. It was like all research stops, which might, you know, or at least paper writing stopped.
Well, I mean, I used to be great at coding. It was MATLAB. MATLAB is dead. No one's been using MATLAB in a long time. My Python skills are like really rusty because the students usually do the coding. But all of a sudden, I'm better than them at coding because I know which prompts to put into systems. So I do think that like that LaTeX thing, we can generalize, which is a lot of like the simple syntactic things of algorithms we no longer need to teach. Now there's the logic behind the algorithms, and that, like, no insult to like your product, but like the logic is not so good even with Anthropic, and so I think that basically the basic mechanics of coding we can near perfectly offload. You understand the answer is like move the microphones.
We're the moderators. We're not on the panel.
I didn't know.
Maybe I'm going to answer like the opposite question, which is like, I think so in computational biology, which is what I was doing before this job, there is an interesting era where data got really big, and you started to need to like learn how to code to like process any of it. And then you had people kind of coming through where it's like, what you know how to do is like how to like write the data processing stuff, but like you don't really know much about how any genes actually work inside of cells. So you're like missing the qualitative biology, but at least you like know how to run the stuff through, and you can make the plots that's essential to get your first hits. And I think that like that era is about to be over, where it will turn out that I think a lot of that, how do you manage the data, like write the software to do that kind of processing, will become accessible again through the models. And it turns out that like biological taste, which is like a thing because that's a very murky system, is going to get sort of a renewed level of importance, where like just like what is the experiment you want to run. I think another piece is like this also in the biology sphere, where experiments are just super collaborative because you need all of these different expertises, and very often you've got like the person who did the electron microscopy like doesn't understand the protein engineering, et cetera, et cetera. I think that being able to have one person drive the science again will be more possible if they're able to like get spun up on like the weird stuff that you sort of didn't know about. And so I'm really excited for like the like motive force of like, okay, I want to understand, you know, like how the mediator complex is working in this disease. And like, you can just like push on that as a person in a way that I think had gotten hard with all the technologies involved.
So they touch on nearly every single piece that we do, right? So I want to add one more piece is I think literature search and finding the right paper to read of this whole area. So that has changed for me. I mean, on top of the coding, LaTeX, all that stuff have happened. I'm not saying these are obsolete skills, but I think they have been dramatically enhanced by these tools that were being built.
Well, Russell, I think your question is slightly ill-posed in the sense that if, you know, I think it's very mysterious how we do something creative, in particular, how we do research. If I were to ask you, you know, what skills do you have that have enabled your research, I think it would be very difficult for any of us to answer. If we, you know, it's one of the hardest things to quote unquote teach if we, you know, are egocentric enough to think that we can teach that to our students. So it's a very difficult question even for ourselves to understand. What are the skills that enable us to be able to do research well? So, you know, one thing that comes to mind that maybe is common to all of us who do sort of a mathematical related discipline is the skill of reading papers. Although even that can be, you know, helped with a good student who can explain the papers to you rather than you yourself reading the papers. So, you know, trying to understand what could a program or an LLM sort of replace when I don't have a good understanding myself of what's going on when I'm doing mathematical research is just, very hard to answer.
There's this feeling of like trying to sharpen the intuition that you have, and if the body of knowledge is like some convex blob, you're like trying to like push the corner out a little bit. And I think that these models have gotten extremely good at forms of interpolation, but that kind of like what is really happening here, that I think a lot of good scientists feel like physically bothered by when it's not that way. Certainly the ones who end up becoming mathematicians are like perversely upset when things aren't sharp in that way. Like I think I mean, maybe someday the models will be able to like also do that, but certainly like following that instinct and using absolutely everything you can pull in that direction feels to me like that's like my like somatic sense of doing this is just like, ugh, and then it like clicks and you're like happy. And I had in spite of desperately wishing it, like I have not found that the models can do that.
But sometimes it's important, at least for me, sometimes it's very important for me to remain confused for a long period of time.
Is it important or it's just inevitable?
Both for me, both. But it is that, state of kind of confusion and frustration that is some sort of important part of a creative process.
What was your phrase for that?
Epistemic humility.
Thank you. I learned something. It's good.
I was trying to coin what you were trying to say is like pushing the boundary. And I think picking the right boundary to push, like a research taste, an area you're going to go in this, despite everyone else saying this is a terrible idea. That is like research taste would be good to teach the students. I don't know how though.
And in some sense, this is about what we mean with a good world. Like a good world is one in which we have elegant ways of thinking about math in that area. And that ultimately comes from us preferring that world over another. Like for an LLM, the logic would be very different.
Yeah, my good world might involve some other things other than physics.
Maybe, yeah, we have a couple of audience questions trickling in.
Already?
Yeah, I mean, also a little bit before, because you guys seem to be more like, like we're probably like, we don't know really how we actually do research well, right? So probably like we can't really know, or we can't expect that LLMs might take that over soon.
We're not even sure we're doing.
Yeah, we are doing it exactly. So how do we what do we even do, right? I mean, so then there's a question about which goes closer to another question we had thought about. So if a rising high school senior asked you what the safest college major to choose, what would you tell them? So it's good.
Great question.
So is there any taker on this?
Well, I think the answer is really clear. Like anything where we use our body will be safe for a long period of time.
So that's what
anything where we use our body for doing wet things, even better. So trained to be surgeon is the ultimate because your hand are all the way in some very...
There's also surgeons.
Yeah.
I think Shirley had an answer about using your body to do wet things over lunch that she thought was a safe career option.
Which one? I don't remember which one.
Okay. Very old profession.
Oh, you're plumbing.
Yes.
It sounds way more interesting than you were making it sound like.
Yeah.
Yeah. I don't know if you should tell high school.
Mike.
Should we tell high school senior that they should be concentrating in plumbing, construction, HVAC, and then what else, guys? I mean, surgeon, they have robotic things that they're going to
childcare, education.
Childcare, but yeah, education, they can just use, some version of LLMs.
No evidence that LLMs are even close to how good a human teacher is. If anything, they seem to have a negative effect.
You haven't been to American public education system.
I have 3 kids in the American education system.
Oh, okay. Yeah.
Okay. Are there any comments from the audience on this particular teaching one?
Suggestions.
I want to know.
Yeah, please tell us.
Okay, so I've heard about mathematical skills and creative process. how important are communication skills?
Because use your body communications in most cases, and therefore, no, unless you're online, and therefore communications is a reasonably safe direction. It's also often communication, like communication, that's like the cynical answer, but like there's a deeper answer to that, which is communication is ultimately about you and me finding a common goal on how the world could be better. For that, I need a very good model of your notion of what is good in the world. For that task, it's very helpful that I actually have a very similar brain to yours. So I think we might have big advantages because we can use our brain to basically go out of the distribution of arguing about good versus was world in the past.
I guess two notes. One is physical resources are still, bounded. And so even if you're able to squeeze more, information resources out of chips, like there's still decisions about like what to do with the stuff in the world. And that those are questions of priority, as Konrad is saying, that like, talking about is important. I think two other notes. One is that like, so my colleague is probably the person who gives Claude its personality. So Amanda Askell is a philosopher by training. And her take is that has been extraordinarily useful because being clear exactly what you want, both like in a conversation model, but even more so in specifying how the model is supposed to be, whether you want it to embody like a particular action in a moment or a particular value in a moment or a particular like way of relating to the user in a moment and be humble about what values might apply, like you just have to be sharp there. And that sharpness is especially important if like your words can then begin to trigger a lot of action in the world. And so I think it's important as a scientist, but I think like as a bunch of the other detail work goes away, then the communication is the core.
And you mentioned a bunch of stuff that will be replaced by AI, and I'm sure that many of it will. But I'm curious how much of it, even though it's replaced, you still think it's important to learn. Like I want to actually go there. And Joshua mentioned, for example, the pipeline engineering for computational biology. I'm wondering, even for something like that, just as an example, I mean, the question is for all of you, like, okay, sure, I'm sure that you need to learn to write many fewer Perl scripts, but will the biologists that don't know anything about, don't understand like how a computer stores data and what, how things work, which is, the current state, I think, with many biologists, will they be able to effectively use, will a person like that be effectively be able to use these tools to do what you want? And same for like, programming or math or all the other things mentioned here. Or basically the question is how much we need to learn to teach and the skills that will be actually replaced.
This is a long question. I think there's a lot to learn still from, both the programming and the math. Like, I think we had this in the lunch discussion. You probably still want to hire, well, I'm paraphrasing. You probably still want to hire someone who has some idea of programming, even though a lot of it might be replaceable, right? At least made way more effective with the appropriate models. So, but then the question is, how much do you teach them and where do you stop, right? How much of software engineering should we teach? Should we still teach software engineering? So there's a lot, but you have.
Yeah, I was just going to add about what I think is the right analogy. Like if we view it as intelligence, I think we're already making a mistake. We should view it as power tools. Now, like you have an electrical drill, you could never drill a hole nearly as fast. And not only that, but you could definitely not drill a hole as precise as that machine. So in that sense, sure, an LLM might eventually be able to be really good at things, but in reality, there's a process, there's a pipeline. I look at the world, I find that there's something missing. I gather the relevant resources. I do some intelligencing. I ask people about if they agree with me that that's something in the world that we should change. And ultimately, we use effectors, human bodies, to change that aspect in the world. In reality, the piece that feels like intelligence is a relatively small piece of this. It's a piece that we are mostly already pretty good at it. It's something that all of us in this room, we sit in that niche. Like that's how we monopolize kind of progress in the world, because it's a necessary part. There was a time where being really strong monopolized the access of like really kind of like cutting a tree into pieces very, very quickly. That went away. The access to kind of simple lookup type intelligence is going to be much easier for everyone. In reality, intelligence is a small part of that overall pipeline. A lot of it can fundamentally not be replaced. And instead, it's going to be like a power tool that everyone uses, and that kind of becomes part of everyday life.
This reminds me of the high school seniors question on like, what is it sort of safe to study? And it's like, kind of, what are you interested in? I suppose that if you're at the point of technical education, which is maybe I feel it's like the last like year before you want a job or something, like then maybe you want to like adjust to where the market is then. But I think that we're seeing like a lot of I feel that this is like the class. Well, a lot of the jobs of the future haven't been invented yet. But like, I think that when I think about the software question, right, you know, I think that like, you know, I don't understand how compilers work. I like never took that class in college. I'm really glad people do. And there are still people like writing new compilers, and there's like just-in-time compilation is like a whole thing that like people invented and is getting a lot better. And like there are going to be things that you cannot do and that LLMs cannot do or whatever without a significant investment being made to like improving some other piece of it. And if you're not interested in that part or aware of it, then like you're simply not going to be able to engage there. And I think that like there's all the whole surface area, like it will still exist. It just feels like the amount that one person can sort of safely access, like for example, like I love power tools because it lets you like build furniture really fast. Like I got one of those beds that has like 80 screws in it because they're like flat pack shipped, and you just like put your whole bed together, which is the modern era. And like I was doing that with my hand, and that really sucked. So I just like didn't have a bed for a few days, and then I like borrowed a drill, and then I got it done in 5 minutes. That was like a big improvement. And so I do think there are cognitive tasks like that where I'm like glad to release it. But anyway, that's the end of my answer.
Okay, so there's one more. Okay, yeah.
Sorry, you're the moderator.
When you would place.
So a lot of what we've been talking about here has been focused on skills that I can sell and doing science. And I come from political science, which is skills that you can't sell, but focuses very clearly on what you were concerned about. What sort of world do we want? What is good? And I'm kind of having some trouble with the idea that these things can't engage with that world, because philosophers have just been reasoning for years, and these things seem like they do a halfway decent job. Certainly using the sorts of entities that you find in philosophy. It's not numbers, it's concepts, which these things seem like they're good with. So I could see, just Josh, like you had the joke assessment, I could totally see asking an LLM, give me a utilitarian analysis of this bill. And to take the response potentially seriously, and to throw another wrench into this discussion, I take hard determinism as a particularly persuasive position, which makes me think that agency is just kind of an illusion we use to justify social cost, imposing social costs on people. And it works, right? Like people respond, but it's still, if you don't believe that anything has agency, then what would separate these things from us?
I don't think there's much doubt that, I mean, like, if we say that humans have agency, or if we say that humans don't have agency, I'm not sure if that's consequential, right? You can say we're the ones having power, and for the time being, and hopefully forever, and we have highly correlated with one another notions of the good life. You know? Like if Russell and me like look at 1,000 random ethics problems that aren't designed to make it hard for us to agree, we will probably agree on 99.9% of this. So like, I think humans very much have a shared notion of how the good life looks like? Okay, we have a shared notion how the good life looks like. And I think we generalize out of past domain in a similar way. I put you and Russell on Mars on the colony, and there's like a weird new ethical problem that is totally context dependent. You will probably come up with very similar answers to one another. And in that sense, you can say that we really do have agency, and we have the power to make our agency be the measure of how society and the world should evolve. And now you can say from a political science perspective, are people stupid? Yes, but are people good at reacting to threats to their own decision making? Yes, they're good. So if we at scale get like manipulated by ML systems, we will kind of get together and like do something about it. And so in that sense, I'm not that worried in that space, but I do see the point.
I'm not worried. I'm optimistic, right? I can see this being a good way of making judge.
Yeah, and like as a power tool and for political science, it's wonderful. No, like tell me which policies were actually implemented by this politician. It's going to be good at veridical information about it. And I liked your example of like, give me utilitarian analysis of this policy proposed by this or that party. Super useful power tool analogous. No, like it's kind of like someone who knows the art would come up with a very well-defined, in a way, simple answer. And like these systems will be great at it.
Yes, nowadays, maybe one thing that Frauke was talking about, that you can even survey people through LLMs. Maybe do you want to, I mean, basically trying to find out like what we actually want from the world. That some people have started to prompt LLMs to kind of give that information. Yeah, do you want to add a few things? No, okay. Okay, so I just want to add a couple of audience questions maybe. One was actually seemed to be highly rated, which is Terry Tao said that GPT-01 is a static simulation of a mediocre graduate student. How do we PhD students convince Terrence to work with us and not ChatGPT? Maybe.
I mean, I think luckily that he's interested in like the relational aspect of that and the development of like creativity and the culture of mathematics. And so I think if you know, students, no offense to Terry Tao's students, but like he's really good and has plenty of eager collaborators. And if his goal is just to collaborate on mathematics with somebody, I think like he has a lot of options. And so this question of like why you do things with people instead of with models. I think in the corporate context, it's much different, right? Those are not relational contexts. And there will be a lot of roles where like, if you could replace a person with like a chip, that will happen. And we'll end up seeing a bit of a separate, like, why do I like cooking dinner? I'm not that good at it compared to people who are very good at it. And I have enough money that I could pay somebody who's very good at it to cook me dinner. And yet like, it is an enjoyable activity. On the question of kind of these soft skills in politics, I think that an increasing number of people has kind of been going on viral on Twitter in the last like week or two, have been using the recent Claude as a kind of like coach, therapist, like mediator figure. And I think that one value there is that it is has no stakes in the situation, and then is good enough at just recognizing basic patterns to call you out on it. There was somebody, I'd had this, actually this was a previous version where like I was in argument by email with a friend, which one should never do. And I put all of the emails in there and be like, person one said this, and person two said this, and person one said this. And the model was good at identifying like what the conflict was and what the noise was. And it's suggesting a way of rewording what I was going to say that would be more generous in its interpretation. I think that like generosity of interpretation to yourself and others, honestly to yourself, which is why it's a popular therapist. Like friend was asking about why they're still single, and if they were being too picky, and the model said, well, there's many reasons that you might be selective in choosing who to be with in a relationship. Like, what are the things that are important to you to be selective about? And then so he said those things, and then like, well, what else do you think is getting? And he sat down for 30 minutes and had this conversation. And that twist from like picky to selective like reflection felt, it's not helping you do science, but I think like the fact that the models can be useful for that, which is something we often have trouble with ourselves, is a potential bright part of this story.
I want to follow up your question because I think we were saying, oh, high school senior, what they should be picking. I think you referenced it too, where they should pick what they're most excited about. I mean, you got 4 years of college. It's going to be super expensive for your parents. You should do what you really want. I mean, we kind of missed the whole point. This is all for like get a job when you get out. Because if that's what you want, you should go to other routes of getting college other than education. So that's one point. Second point is that I think teaching something about humanities or like liberal arts education is actually quite useful. It might be a very minority view at this point, where I think humility that you talked about actually gets taught when you learn about other people's stories and history and all this background. So I think that is something we didn't talk about, because these are not hard skills. Hard skills might be more easily replaceable, I think, than soft skills. And that might be something we should tell the next generation. Do what you want. Learn something that you make you a better human, I guess. Sorry. You have to.
Maybe Adam
Go
first.
ahead, on the back. Yeah.
So in today's world, there's this big conflict in the academic world about, oh, you stop, it's like a calculator. They don't want you to use ChatGPT to write papers and things. I think what we should be doing is teaching how to use that intelligence to boost it to the next level. So Doug Engelbart, who created the mouse, the icon hypertext, and all the internet stuff, his idea was to raise and boost human IQ, right? And be able to utilize these tools in a collaborative method. We should be able to have classes where we teach our students how to utilize these tools to raise and boost humanity. I mean, how did we do this?
So, this was actually on our list of prepared questions. I think maybe Andre had suggested it, or
Adam starts.
Oh, okay. So
No, I mean,
what would you teach in a class on how to properly use AI in your research?
Well, I think, you know, as Nati said at lunch, we have calculators, but we still teach arithmetic. I think the more interesting kind of question is, when I think about biology and AI, there's a mapping that goes on from a biological question to a machine learning question. And it is coming up with that mapping that is very interesting and very difficult. And, even if you have kind of, super powerful power tools, as you would say, figuring out how to come up with that mapping, even when I think about my kids doing math after they've learned arithmetic, understanding, the mapping from, say, what will slow them down. I mean, they can breeze through the arithmetic, but what will slow them down is a word problem, because it requires sort of this type of mapping. So, and the process, like once you've gotten your scientific question or your scientific problem to a point where it's already translated into a machine learning question, I think that you've already solved, the hard part. And so, I mean, you've reached the easy part of the question. It's, just figuring out, like, how did I arrive here? How did I translate this problem into a machine learning problem, into some sort of other problem that is fascinating and difficult. You might want to call that critical thinking. I'm not sure how we teach that in our classes per se. Did someone raise their hand there?
Let's go with the panel for now.
Yeah.
Yeah.
Okay,
We only have 10 minutes.
Gotcha.
Oh, we have.
So I can answer that question well, because I tried. So I tried last year to teach a course of basically how I would teach students to use the tools well and become better thinkers through it. And the things that I focused on included basically the standard mistakes of the human mind. That includes correlation causation issues, that included epistemic humility, like how well do people know what they don't know? And they tend to be very bad at it. That included things like, what does it mean if I can predict something? what does that mean about how the world works? That included meta-ethics. Like ultimately, a lot of people, in fact, it's horrendous if you ask computer scientists, they think that they're all utilitarians, and none of them are, and they're deeply, deeply confused about the commitments of their own life. And basically, meta-ethical ways of thinking, kind of all those things. And it was a disaster. So half of the students told me it changed their life and sent me emails months later that this was the best thing ever. And the other half didn't know that they didn't know how to think. It was entirely uncorrelated to their ability to think, but there's most students don't have an awareness of the blind spots in kind of their intelligent process. And so in that sense, like I gave up on that course because I can't make it work for like an overall population of undergraduates, at least, even at Penn.
I think even all the things that you mentioned don't get it, maybe the most difficult and fundamental problem, which is that I mean, I think we all have, is I don't know where to begin. I'm stuck. I have no idea how to proceed.
You mean in life in general?
Yeah. yes, in all things.
So, but why do you think it's not getting at that?
Yeah. But let's hear what the other panelists.
This is good. Let's get
it.
Okay, no one else wants to talk?
I'll talk after popcorn.
Okay.
No, like in which way, like if you're stuck, that's part of a process. Now, like as long as you know how you want to, if you know how you want to change the world, there's a piece of that process that you can't get it. And LLMs are wonderful power tools for that. Now, like I decided my house should be painted red. How do I get red paint? Like it's going to be great at
right, but I would be like, I don't even realize I need to paint my house.
So but in that sense, like as long as you know that you're stuck, as long as you know that you're stuck, there's a process of dealing with it, and a process that I think is teachable. Like I'm unhappy in my house. Well, what do you think is wrong with your house? Well, I don't know. It's like it feels a little oppressive.
How do you teach that you're stuck to realize that you're stuck? Right.
They call them problems for a reason. So we can give them things to be stuck about and motivation to try to wiggle out of the feeling.
But you said you know that you're stuck. Tell me like about that feeling.
Maybe a common problem is, say, writer's block, let's say. Right, I know that I want to.
But that sounds like you know what the
I know. Yeah, I do. I want to write a novel. I personally say I want to write a novel, but I'm stuck. I don't know where to begin, what to write about. I have fragments. I think it's a common, and I think struggling with that problem is important, and is something that whether or not that's sort of a skill that can be taught. I mean, I do think it's important, and if you ask writers, they will tell you have a ritual, have a schedule, make sure that you're doing the same thing every single day. Be disciplined. Those are kind of hacks, but maybe there are other deeper psychological problems that are causing you. Maybe you're afraid to write your novel. Maybe you realize you should be doing something else. But I'm not saying that being stuck is bad, and actually, it's very interesting in a fascinating way. But the things that you enumerated, kind of like understanding that I'm stuck, it's not clear to me that. Or being aware that I know that I'm stuck are going to necessarily help me with my writer's block.
Well, so usually the reason that I'm stuck is like a paralyzing degree of perfectionism, and because as soon as you write something on the page, your judgmental intuition clicks in, and you're like, well, this isn't the answer yet, and so you like rather than expose yourself to your own like terrible wrath, you're like, I'm just not going to put anything on the page. And I do think that like the way out of that is you can try it yourself. You can also have somebody like ask you questions is valuable. This is actually an area where I think the models help unstick people from writer's block, because you're just like, I'm stuck. And it's like, why? And you're like, what are you trying to do? Like, I want to write a novel, blah, blah, blah. It's like, okay, well, what have you done right now? And you're like, I'm nothing. And it's just like, well, like, what about this novel do you why do you want to write the novel? And you say something, it's like, well, what do you know is true about this? And then like you get in a conversation and you kind of like get moving, like
You feel more and more depressed.
around the, well, I mean, sometimes you like, you become aware that like, maybe you didn't actually want to write it and just your like father wanted you to write it. And like, that's why, you know, you're sort of not, sometimes some of the answer is just don't do the thing. I will say that with respect to like the classroom and learning, like, you know, we give people pretext tasks, which are supposed to like, that they can exert themselves against. And in that exertion, like they get stronger and they grow. And when you give somebody technology, they might not need to exert themselves at all to solve that task. And if so, there will be no growth. And every time that happens, like, because you can feel, it's like when you're at the gym and like the weight isn't on and you're pulling the bar and you're like, look at me, I'm pulling the bar. And it's like, well, the point wasn't really to move the bar, right? The point was to do it in a way that was hard for you. And if it's not feeling hard, then like you have to adjust that or you won't learn. And I think that like, the question of like what to do when certain things become easy with a tool is like either you can ignore that, but then you won't learn or grow in that way. Or if you want to learn and grow that way, you need to find a new way to do it. I mean, it took me like an upsettingly long time to learn my new home address. I moved 3 months ago and I would just like look it up every time and then like write it down. And I never triggered the like pain of like remembering it or whatever. And same with getting to the house using Google Maps to like drive there all the time. Then I was like, I don't know how to get to my house from my job. And then I just would like look at the map and then put it away and then like occasionally get lost. And then now I know how to get to my house, which is good. But like it was too smooth. And I think the fact that like, you know, oh, like the thing wrote my paper for me. It's like, well, congratulations. Like now the weight is on 0. And then you just have to.
But we're also treating being stuck as as a problem. Maybe being stuck is the right situation to be in at that moment. And you know, in weightlifting, I mean, what you're describing is progressive overload, as it's called.
Yeah.
But there are many times when you will be on a plateau for a long time, and that's necessary and important. Yeah.
No, I was just about to agree with you guys. Maybe we should teach struggle to the students. Maybe we can call some struggle, call some stuckness, whatever you call it. Because I think failure is important. And I think, at least for my generation, we had to go through a lot of pain and suffering. I'm hoping maybe this is just bad, that we have some pain and suffering for the rest of the younger generation, just a little bit, so that you feel the pain pulling out down the bar with some weight. You have some stuckness, you have to be there. Sorry.
So how many people here know Latin? Okay. Ad astra per aspera, my favorite Latin saying. Does anybody know how to translate that? Astra, you should know that. Stars. To the stars, through struggle, through striving. And I think that's what you're talking about.
I mean,
You
this
may
is
say it
Plato's
much more beautifully.
philosophy of education, right? You needed to kick and see where it gave and where it pushed back. If you were really going to assimilate a concept, make the kids do math homework. Don't just give them a lecture. So yeah, their struggle is absolutely necessary.
They knew it from Latin days, so we didn't invent new things.
They knew it more Latin.
Holger, did you still have a question? No, I think we can do a bit more. No, actually, we can. Yeah, we started late.
This is related to the skills, but slightly twisted, because observing us here this last semester and trying to do research around LLMs with them or about them, I wonder if you have a sense of how do you teach to do that well? I feel like I'm observing this field as being all over the place in its methodology. And I wonder what are sort of the core things that you would teach that should be done in order to do that kind of research well?
So I'll say one of the seductive things about language is it's very resonant. And so it's possible to do like a ton of stuff that doesn't add up to making any claims. And I think that like there's a lot of wisdom in like, so I think there's almost like, okay, there's like, are you on a sort of more humanistic side interacting with this and you want it to be magic? Or are you on like a more like mathematical side and you will just sort of like take a cursory glance at whatever like the linguistic content of what's happening is and then sort of move on? And that you need to like really have the epistemic humility that like these things generate great plausibility. They will like superficial analysis like is sort of unsatisfying. I think that like what that means is like you really have to kick the tires on the claims you want to make from all sides. I think this is general scientific advice, but it feels particularly treacherous with these. And I think for years, I was saying in computer science, there was this curse of like the benchmarks. It's good to have benchmarks, but then you just like try to make the number go up in a way that doesn't generate any like unknown generalizability in the future of like they don't generalize at all. And so I think that really pushing each other not on just like, is this engaging to do, right? But like is this a falsifiable claim in some way?
I think there's a method that one can learn and that one can teach. Now, if you look at a scientific abstract, it starts with a gap statement. This is what is missing in the world, and if it was filled, the world would be better. Then it has a to fill this thing sentence. Here we to fill this thing. Then it has a sentence, what you find, and then it has a sentence of how the world is now different. This kind of structure is the structure of scientific thinking. You start with, let's have a question. Let's have a question, the answer to which would be consequential. And once we have that question, then how can we answer that question? And then once we have, how can we answer the question? What is the answer? And then is like kind of the rapid back. Now that we have the question, how is the world different?
Do you actually do things in that order?
Yes, absolutely. So I said no, let me be clear about my process. Now, every lab has its own process. In my lab, students write abstracts before they're allowed to do any coding. No experiments, no coding, no math, until they have an abstract. And the abstract must have these components. What is missing in the world? What's our idea on how to fill it? What do we imagine we'll find here? What will it mean? And we iterate on this 100-word thingy until like the students and me are on the same page there. And at that point of time, then they go and code, and they're much better than doing that. That part, that abstract making, that like making the idea is the one piece where as a professor, you can't replace me by the wonderful products that you guys are building.
We'll see about that. But I do agree that process, whether it's being run by a model or by Professor Kording, is very useful. I guess sort of what I meant by like earlier is that the friction gets very low for these experiments. If you are going to spend like $20,000 and 3 months of your life making a transgenic mouse, right? You had better like believe that you're putting the right gene in it. And so quite naturally when like there's that investment, I think that systems evolve to like set a high standard for like it being worth it. And both your PI is going to make you do that, and like you're going to do that because you don't want to like waste 3 months of your life in your PhD. And when it's very easy to just take a bunch of marginal steps, you can basically just explore around things that have fun vibes forever. And so I think in this purely electronic realm, like it might feel unnatural to begin with this level of definition because it's so easy to move.
I just want to mention, I don't know if you guys heard of this AI scientist built by Krzakala AI, that they're able to write ML papers. I mean, they make the hypotheses first, then they run the experiments, and they kind of loop the whole thing as they see what happens. So which is very similar to our research workflow. So if it's purely computational experiments, it gets, I'm curious the papers they generate, how different will be, say, from your group's papers. And would the difference be distinguishable by the model, which will be great to learn from your group's papers if it's truly distinguishable, and it learns to do better, right?
Can you write that in the format that would qualify for in this?
It might make the world better if you have like an automatic AI scientist to do at least computer science, at least computational science experiments.
I think one interesting thing about that proposal, right, is that you can actually have the arguments at level of the abstract. You might think that like the writing the paper is the hard part, but I think that like there's two questions. One is, could it write an abstract that, if true, we would find valuable? And that's a fast thing for us to check. And then the second question is, indeed, did it manage to like demonstrate that? And I think that I've seen more work on the latter part than on the former part. It often, you set very like cookie cutter style paper goals where it's like, maybe this architecture would make this number go up. And then you're like, you run the thing and maybe the number goes up or not, but like good abstracts.
Yeah, I mean, like, look, like, can such a system like write NeurIPS publishable papers at this point of time? Yes, because there's a very cookie cutter, not like you have like one idea. It's not a new idea. It's an idea roughly 10 years old, maybe 20 years old. You pretend that you're the first person to have that idea, and you show you have like a cookie cutter proof that goes with it, and you show that it increases SOTA by 3%. Like we know how these papers are made, but like, I'm sorry, my group doesn't publish those kinds of papers.
But we can make the model publish this kind of papers if we train on your data, right?
That's right, and it's possible that NeurIPS paper are already successfully written by those models.
Why would we want to do that?
See, I'm just curious when it's possible.
So and let's be mean to humans too. Like I've just been mean to LLMs. Like there are plenty of papers written by human beings that also aren't useful in any meaningful way. But the papers that are wonderful, they derive from like an understanding of how the world becomes more elegant by rethinking an idea. And this is something that I've seen no evidence whatsoever that LLMs at all are picking up that idea. There is something about like, after doing that, after rethinking the idea, it now becomes something different. And this kind of transformative change, we seem to be a long way away from it.
There is a kind of paper that with large language models is interesting, where you might get like, suppose you're interested in like the representations of some linguistic tasks across languages. And for that, you want to like construct a data set, which is like paired examples in a bunch of languages of like some specific thing. And then you look and you find this mechanism in common. That is like a cookie cutter shape paper. And to do it rigorously, you need to define the thing and like make sure the data sets are good, et cetera. But it's not rocket. You give it to an undergrad to do round 2 or 3, and like they can learn about the field from that. And like it's a marginal progress, because having an N of 1 is something. But if you've got N of 30, where this kind of analogy holds, you start to feel like there's like really good evidence for that. And it does seem like, you know, I'm trying to build the tooling such that our language models can like one-shot those papers, right? Where it's like, you know, given a paper demonstrating this kind of phenomenon, what are analogous phenomena that might be true? And if it turns out that they're not, that's quite valuable information. And if it turns out you can build out the body of evidence that that sort of is, and in some sense, that's the kind of like training wheels science that like at the same time, you do want to build up, you know, evidence for, and it feels sort of confirmatory. And it would be nice if one could, and you know, in silico, you can actually try to do that.
Now I think we're really actually going over time, even with the late start. So what I'd like to do is like say, does anyone have any short last words? If not, let's all thank our wonderful panelists.
There's going to be a reception right outside here for the workshop. So yeah, we can talk more offline. Yeah.